Hi everyone, this is the fifth tutorial video for regional analysis course, and here I will introduce you how to calculate the Hoover index, another name Robin Hood index, and how to calculate the unweighted GINI index. Which are the last indicators before the first test. The next week we are going to practice all of the indicators and all of the maps, all of the analysis we gonna practice, and I'm going to make a video some examples for the advantages of the calculations and the analysis which we made in this first section of this course. But before that, I will and I'm going to introduce you to the Hoover index and the unweighted GINI index, and before that I will show you the formula for the Hoover and unweighted GINI as well. So the Hoover called someone called it Robin Hood index as well, because we can calculate for two variables. We can compare two variables for the distribution from two variables. How can we distribute it differently? These two variables. For example, in this case, x and y variables datasets distribution have compared in this case. So we compare absolute indicators, two absolute indicators, but if you use two absolute indicators, and make a comparison of it, you can call it the Hoover index of the division of it. For example, if you use the population, absolute number of population, and area, make a comparison of these two variables, you can call the population density the Hoover index of the population density, because population density is the division of these two variables. So if you make the calculation for the population and the area, for example, you can call it the Hoover index of the population density at 2006. Okay, make the calculation. First of all, we have to calculate the summary in the denominators. We should calculate it. Sum, equal sign, and sum, and select all of the data and grab it to the all of the cells. Just make the summary all of your variables. After that, we have to insert another column after the population 2006. Insert sheet column. Okay, and in this cell we calculate this number. The lines means the absolute function, so we have to use the absolute function, the first, and bracket, and area divided by the summary of the area, because of the formula. Here is the area of the given spatial unit, and divided by the summary of all of. Okay, here we are. It's not G, it's I. Okay, the formula is in that form is wrong, but we have to fix the area because we just grab all of the and calculate automatically all of the spatial units, so we have to fix the area, and population as well, and divided by the summary of the population, and fix the summary of the population. Okay, we don't have to use any square or square root, so any of it. Okay, and automatically calculation for all of these, and make the summary for these numbers and these differences as well, because in the formula we use the summary sign. Okay, and the Hoover, just for the Hoover we have to use just the divided by 2, and if you just use the percentage form, you can look at your number is very well. So this means we have 16, almost 17 percentage for the Hoover index for the population density at 2006. This means that we have to move the almost 17 percentage of the population to another spatial unit for an equal distribution, not equal, for the area proportion distribution. Okay, so not an equal distribution, not all of the spatial units has equal numbers of population, but if you move to the right place, to the right spatial units, the 17 percentage of the population to a right spatial units, we can make an area proportion distribution for all of these spatial units would have the same population density number. Okay, and after that we should calculate for the population density 2010 and 2015 as well. Insert the column. Okay, and make the absolute differences between the population, the share of the population in a spatial unit, and minus area, share of area of the given unit. Okay, grab it for the automatic calculation, and summary divided by 2, percentage form, and we have an increasing number for the population density, which means that we have unequal distribution and increasing inequality of the distribution of the population density. So we have to move more population to the area proportional distribution. And 2006 absolute number. Okay, share minus area divided by the summary, and okay. Here is the summary, and here is the Hoover index percentage form. So why someone and lots of people say that this is the Robin Hood index, because it shows us the size of the given variable for the how many people, how many money, how much money should we should move from one unit or one people or one spatial unit have to move another spatial unit to the right and proportional distribution. So if you have for example the GDP, we can calculate the GDP for the population as well, so we can compare the 2006 GDP and population. We can compare with the Hoover index. You should for your homework and upload everyone the calculated Hoover index for the unemployed people and the GDP as well. So the unemployed people, in the case of unemployment, if you just compare the unemployed people to the total population with the Hoover index, we have the number, we have the percentage number for how many of the unemployed people have to move from one spatial unit to another spatial unit to have every spatial unit in the same with the same unemployment rate, because we have huge differences between the spatial units in unemployment rate, and how many unemployed people have to move in from one unit to another place to equalize these huge differences. Okay, one thing I want to show you, insert one column. The unemployed people, in the case of unemployed people, we have missing values. So in the calculation of Hoover and any of the indicators, we have to use the form but minus population, not an area, because the unemployment rate we use for the unemployment rate we use the population as the weight. So we have to use for the comparison the population. Okay, and make the calculation, but we have to delete this number because if you just make a calculation and miss this value, this is a difference between 0 unemployed people and 0 share of the unemployed people with this number of population. So 0 means that we have no unemployed people in that area. But in this case, this is not the case in that case. Sorry for the repetition, but here we don't have 0 number of unemployed people. We don't know how many, so we have to miss the calculated values as well, and delete all of the calculated value, because if we just make the calculation, okay, and make it right, we have a totally different number for the Hoover index, because if just delete it, 4% less. Okay, so we don't have 0 number of unemployed people in Mazovian region. We don't know, so we just have to miss from the calculation. Okay, the task is make the Hoover index for all of the unemployment rate, for all appointment, and GDP per capita as well. You have to make the calculation for the GDP per capita at every appointment. Okay. After that, we have to. I want to introduce you to the unweighted GINI index. Here is the formula for the GINI, the unweighted GINI. In this case, in the GINI case, we make a comparison between one variable, but we are curious about which is the average differences between the variables in one dataset. So we have difference, for example, the GDP at 2006 between Prague and Central Bohemian region. We have 30,000 million euro in Prague, and we have 13,000 million euro in Central Bohemian region. We have a huge difference between these two regions, but we are curious about all of these differences. Prague difference, Jiho-Západ, Prague difference, Severozapad, Prague difference, Central Hungary, and etc. etc. So for all of these, and this is the difference. and for all of this calculation we have to make a matrix for it, and just delete from name to unemployed people at 2015 and 2010 also delete, and select just the code and the GDP at 2015, and Ctrl C copy, and Ctrl V paste it, and make sure that there are at least 3 or 4 cells between these two table. Okay, paste it and just delete the 2015. So we have the GDP 2006 and we have the GDP at 2015. Okay, select all of the variables, all of the GDP variables, and Ctrl C also, and make a transpose paste, because we have a matrix with 2 borders, and in the cells of this matrix we can calculate the differences between all of these values. How? Click on the cell, the first value below in the matrix, and after the, so we have to make the differences between this and this. So this difference will be 0, but if we fix the right cells, the matrix will calculate automatically all of the differences. For example, we have to fix the B. If you just type $sign algebra before the B, this fix just the column, and if you just grab it for the other the right hand side, the B is fixed. Okay, but we have to fix the one row as well, because we have to make the calculation for the below side. Okay, grab for all of the variables, and if you just don't write everything, you have a 0 number parallel. Oh, not parallel, diagonal. Okay, and grab it for the 0 number will be in the left hand side. Okay, here is the all of the differences between all of the variables themselves as well. Okay, and after we have to divide it by the summary of those all of the values. We have to divide it by 2 number of cases, which is a very important things, because we will use a number in the Excel formula, but every case you have to count the number of cases before type for the Excel, and divided by the average as well. Okay, so we have to calculate the average, not this from this mean, and after that we can calculate the Gini as well. Select all of the numbers which we calculated and bracket and divided by and open bracket 2 multiply by how many units in Visegrad 4 countries. We have 35 units, so we have to multiply by 35 twice and multiply by the mean. Okay, that's the Gini index for the absolute values for the GDP and 2006. Okay, after that we can calculate the Gini index for GDP at 2015 as well. Transpose and make a difference. This is a most important part of the Gini index. Make a difference between this cell and this cell, and fix the B for the left, and fix the number, the row number for the upper cell. Okay, and grab it for all of the numbers for the automatic calculations, and if you have the diagonal zero numbers, okay, you just make sure that you have done the right thing. Okay, after that you can average. You can calculate the average number and the Gini as well. Select all of these numbers, but the original variables you have to miss it, because we just calculate and we just summary the differences, not include the don't include the original numbers. Okay, close bracket, divided by open bracket 2 multiply by 35 and the average as well. Okay, so we have a Gini, an increasing Gini in the GDP, but this means that the 1/3 of the average is the average difference between the values. So the average difference between values is 5,000. Okay. Okay. You have to you can make a calculation for any other variables for GINI, but not necessary for the uploading. So after the next week, there will be a practice, and there will be a list of tasks for practicing for the for the first test, and there will be a video for given. I will give you examples for the importance and the usability of these analyses and of these calculations. Okay, thank you for your attention, and goodbye.